So for today's training, Brian, I'm hearing my echo
I'm
here.
hearing my echo here. All right, I'm gonna shut the microphone off then.
All right, so it's better. So today we're going to do training for fully attentionless case, which we're going to use a case for the patient uh, we got earlier, Sergio, I guess. We're going to run the upper jaw case, do a regular tissue level surgical guide, and do a bone reduction guide. So I guess for basic operations, like mouse operations, keyboard operations, we have covered last time. So we're not going to cover this time. So we're focusing on the treatment planning and surgical guide design. So
That would be perfect.
as usual, we start with this new button to pick the DICOM files of the patient scan. So we have the upper jaw with the radiographic guide is in the mouth and the radiographic guide itself, and we also have this uh, STL files of the radiographic guide. So typically we only need the patient's scan with the radiographic guide, and with additional STL files we can actually add into the system, perform surgical guide with it. So I'm going to show the addition of this STL files after we finish the basic workflow. So right now, let's start from the patient CT scan with the radiographic guide. So we go all the way to the folder and type star. We will find all the DICOM files because those files don't come with the DCM extension. So I just pick any one of those and open it. Because we have about 400-500 files, so it takes a little while to load the CT scan. So after we load the CT data, we have 3 cross-sectional views, axial, sagittal, and coronal views, and we also have 2 3D windows here. And as we can see from here, those are the radiographic guides from the markers from a radiographic guide. If we use the mouse button, press left button, move up and down, left and right, we are changing the threshold value, which you can see from the lower corner of the screen. So this is for us to have a quick overview of the case. Like this, we can see a better picture of the bone structure and the markers. In case we have partial edentulous cases, we can see the teeth better. But just move the mouse up and down so we have a quick overview of the case. And also we, as we did for last time, we are not going to use this Express Wizard, but it's I would say it's a pretty good tool for the beginners. And we're going to use this workflow panels. We start from case preparation to treatment planning. We can capture snapshots and bookmarks, manage objects, all the models we create down the workflow, and perform surgical design, generate report. That's pretty much the workflow itself. Basic operation of the mouse and keyboard, as we said, we covered last time, but just to repeat a little. Left button is to rotate, right button press and move it to zoom in and out. Let's take a quick look at the radiographic markers. We have 7 markers here. They are more or less symmetrically distributed. Actually, I played this case a little earlier, and we do have a problem with this symmetric arrangement. So as a guideline, when we make radiographic guides, we want them to be not evenly distributed, not symmetrically placed. In that case, we can actually better recognize the markers and register them faster. So let's see how it goes for now. If we load the radiographic guide CT, we go up to find the folder itself. Get all the DICOM files. In general, we automatically register all the markers for fully extensionless cases. But as I said, for this case, we actually have issues because the markers are placed symmetrically. So we, at the first place, we actually flipped the markers because when it's left and right side are about the same. So this is actually give you a quite close match of the markers, but it is not right. So we're going to fix that later. So if you look at here, we can further load the STL files of the radiographic guide, as I mentioned earlier, and we can do post-treatment CT scan. We can do facial scan. We can lay over a facial scan with patient's CT structure.
Frank, we have a question.
Yes.
Yes. The symmetry you're talking about is the palatal and buccally. They're on the same plane. Is that the issue?
The left side and right side are about the same. So you have one here, one here. So they are symmetric to the center line.
Oh, I see what you're saying.
Okay. Yeah.
Okay.
So
the software doesn't recognize.
It does.
Right from the left
flipped.
is what you're
It is
saying.
flipped here. So we're gonna fix that. So no worry.
Yeah,
But I'm just saying for the future.
For example,
if
you take off this one.
Everybody expects, everybody asks, all the different vendors ask for them to be on different planes and unevenly spaced. You just happened to, and I didn't even notice it. You did a.
I've never had that issue. And maybe I've never really paid attention, so maybe
I think that's what happened. You just happened to nail it.
Super perfect.
Yeah.
I think you just happened to nail it.
That's okay. So continue. So we can load additional data and do the registrations, etc. So let's just follow this workflow. The second step, we're going to segment the upper jaw of the patient. So three things as usual. First, we adjust the region of interest. So we move the mouse, adjust the region of interest a little. And we can use mouse button to go up and down to make sure everything we want is inside this box. So that's the first thing. The second thing is to adjust the threshold. We go up and down to see the best value, where the best value is. If we go too much, you can see we are losing the bone structures inside the cortical bone. If we go too low, we are getting soft tissue. And so we want to go somewhere in the middle, something like this. So we can have a better picture of the bone structure and the markers. Actually, for this case, since we are going to do a bone reduction guide, we want to have a better bone structure. So we'll go as low as possible on this step. So we slightly go lower. So it won't impact the majority of the bone structure. So that's our bone segmentation. The last step is to pick the major piece, which is called a seed point. So we click on this button and pick a point on the bone structure. It's going to get rid of the markers and some smaller tissue structures. So now we have this bone structure. Because we are going to do the bone reduction guide, we really want to have a nice, clear bone model. But if we take a closer look at this, I'm going to maximize this window. From the CT data view, we see it's lots of holes. If we change this view to surface mode, which is similar as what we show STL file, you will see more clear how bad the tissue surface, bone surface is, because this is a normal way we see a bone structure from the CT data. If we do a simple tissue filtering like this to filter the pixels with thresholding. Now we have this button here called tissue pinning simulation. What we are going to do is instead of doing this filter, we consider assuming we are actually pinning the soft tissue, meaning we are not going to pick each of those little small holes. We will keep tissues inside those areas. So what we do is just one mouse button to do this operation. And as we can tell from the CT scan, there are so many holes, the bone structure is really, really loose. So what we want to do is we don't want to adjust this value. This is about the radius of the holes we're going to fix. You see here, much bigger holes here. So let's put it this 3 millimeters. Then I'll click this button. It's going to do the work. And this step is very computation intensive, so it takes many steps to get there, although it's automatic. So it will take a while. We'll have to wait a minute or two. This is a very special step, a very necessary step for bone reduction, bone level surgical guide.
So, Frank, the name tissue peeling is, I think, what confused me. Does it have really anything to do with the tissue?
Yeah, it's like when you peel the tissue, you have the bones remaining. Yeah, it's like when you actually do surgery. Yeah, maybe we can have a better name.
Don't change the name on my account. What it's doing is creating a smoother representation of the bone.
Yes. We'll fill in those holes and make it smoother. And also, it's very important to maintain the overall shape of the bone structure.
Yeah, this is a pretty Swiss cheesy bone.
Yeah. We should have make the area smaller, so we're pretty much at the maximum size of the upper jaw, so it takes a little while. Well, this is for the purpose of bone reduction guide and for printing the bone structure. Obviously, for this at this moment, like this shape, you cannot print in any computer printers. It's just not possible to print. So we got to fix it. All right. Now you can tell the surface is much better than before, and we still maintain the shape, overall shape of the bone structure. If we give this model some translucency, we can tell there are still holes inside. So this bone structure, bone quality really low for this case. Well, so I'll go back to the regular display. That's the volume rendering of the case. Now, let me make this window smaller and we'll continue with the rest of the workflow. If we are not going to print this model, or we are, just for the guide design purposes, I'm going to trim this area, because if we look closer, those areas are still very weak and might cause some booning operation issue, technical issues for the operations. So I just trim those area. Use this scatter tool. This is also the way you remove scatters, remove any materials from the patient bone structure. I'm going to do a cutting operation on this. So this is our basic bone segmentation. In any case, if we want to have some sort of STL files of this one, we can just right click and export STL files. So we finished the bone segmentation. Let's fix the registration here. It was registered before, even though it's wrong. So let's do a reset. So we'll go back. I noticed, well, one thing is the markers are kind of symmetric on the both sides, right? This is one thing. Another thing is I want to ask the doctor, what do we use? What is this shape inside? It's like we actually make a slot between the two markers. I don't know how the markers, how the radiographic guide is made, but the shape, it's okay. I'm just curious. So let's look at this situation now we have. So those are the markers. So we are sure they are in the similar.
Yep, right.
Frank, there is no slot or anything in that. Those are just shear marks.
That just stick on shear markers.
Okay, I see.
I
So
wonder if they're so perfectly coplanar
yeah,
that it's some artifact of the CT scanner.
Yeah, I think a lot of the issues are with our CT scanner.
it's not
Yeah,
it's quite regular, I would say. So because first time we failed the registration, so we're going to specify the markers. So go here,
specify markers.
I'm going to pick
I'm going to pick
I'm going to pick
this one. We'll pick this one.
So I pick 4 of them.
So I pick
cover
four
the
of
entire
them. Cover the entire arch.
on the patient side.
On the
I don't
patient
have
side,
to pick them.
I don't have to pick them.
In that case, the system
In
will
that case,
automatically
the system
register,
will
still
automatically
automatically
register. Go automatically register.
But as we said, this is all symmetric. So a better way for me to go is just find those markers and tell the system they are the corresponding markers. Then we finish the registration. Now you see we have 127 microns deviations among those markers. So we finish the registration. At this time, if we have additional scans, we can load them. As we said earlier, we can do that later. So we have the radiographic guide, we have the patient's bone structure, and everything looks good. And obviously, those markers could present problems as for the surgical guide design. So as in this case, we have the third STL files. Normally we don't, so that's fine. But if since we have the STL files, I would like to add that one here.
We're all confused what STL file you have.
Yeah. Is this from you or actually my guy?
You or actually my guy?
Take a look.
I don't remember. Take a look.
Is that from my
That looks
guy?
nice, but we didn't
have
we didn't make an intraoral scan of it.
Okay, so I guess my guy made it. Anyways, so this is a good way to show you we can load multiple data instead of just two. So we take this one. Yeah, they made
Take
it.
this one. Yeah, they made it. Zero about the similar
location. So what we can
location.
do is
Now why are the markers you think going to cause a problem later on? Because we're going to recommend the SureMark markers.
yeah. Here,
yeah.
okay, let's take a look at. So I'm going to right click on this, make it current. So we see this. If you look at those areas, those artifacts or geometries tend to cause trouble for Boolean operations. Actually, let's try to fix those. I actually shouldn't have skipped that step. So we go to segmentation page. In addition to the bone structure, we have this tab for a template. If we adjust the threshold value for this, oh, sorry, because I loaded this one already, let me delete this. So I delete the last one, and then I tell the system my very first one is the radiographic guide, so that I can go back to, well, actually, you see, it doesn't let me to do that now. So if we go back to the scan template step to adjust the threshold, we can get a better model of the radiographic guide. So if you take a look at this now, the value is obviously too low. The guide itself gets a little bulky. It's bigger than actually it is. So so this is why the radiographic guide based cases tend to have surgical guides that don't fit that well, because this threshold value can actually change the shape, the size of the model, which is not a good thing from the day one of radiographic guide, but it remains there, forever. So for this case, go back to your question, Brian. Very likely those small little holes inside here goes through outside, goes through to this point, and some other artifacts like those can cause the surgical guide operation, the Boolean operation, fail. This is very likely they will. So what we do is we can fix this model by, for example, removing this area, those scatters. I can take away those things. So in a regular situation, you probably don't need to do so, but for this case, so for the sure markers, we don't really like this. I would just go with Gata markers.
Yeah, we got to purchase markers are a little more work for the clinician.
Oh, I see.
Dr. Manley had a question.
Yep.
Yeah, so my question was what you recommend. So besides Gutta-Percha, what else do you recommend?
I would just do Gutta-Percha.
I would just do Gutta-Percha.
Glass beads are okay. People use glass beads.
Isn't that what these are?
Glass beads.
Glass beads.
Some people use the
I mean, these are the SureMark.
Density is too high.
So the problem is the doctors are doing these on their own. We're not making these for them. So it's got to be something they can easily do in their office.
Yeah, I understand.
Yeah, this was
Yeah, I
a,
understand.
this was the patient's denture, and they don't like the little pink dots all over it.
I see. I see.
Like
Well,
this isn't a
Well-
surgical guide. This is their physical denture that they're
Yeah, I
wearing
see,
that we're
I see.
using.
Yeah, I see, I see.
well, but for
Well, but
I actually didn't
I
realize
actually didn't realize
for the
this.
shore markers
For the
because
short markers, because
they are spherical shape,
they are
right?
spherical
They
shape,
have a
right?
single point.
They have a single point.
Theoretically, they have a single
Theoretically,
point
they have a single
touching
point
the guide
touching
itself.
the guide itself.
So that
So,
might
so
cause
that
problem.
might cause
Very
problem.
likely, I would say.
Very likely, I was.
So for shore markers,
So for short markers,
they don't have a flat
they don't have a flat
surface, right? Just the
surface,
spherical
right?
shape.
Just the spherical shape.
Right, it's a little BB.
I see. All right. I would think
I would
tend to have
think
problems
they
for
tend to have problems for
surgical guide generation
the surgical guide
because
generation.
before I
Because,
cut
So
those,
I've used these with other softwares and I've never had this issue. So I'm just curious as to.
well, because I'm trying to tell you,
Well, because
some
I'm trying to
technical
tell you, some
insights.
technical
We may or may not
insights.
have issue
We
with
may or
that.
may not have issue with that element.
Right.
So it's just a possibility.
So it's just a possibility.
Let's see
Now,
how it
let's
goes. We'll
see
continue.
how it goes or continue.
Your treatment plan.
So-
Continue the treatment plan.
So I think for this first case that we do, could we potentially print a couple different guides? Like, can we do one using the sure markers and I can just see how it fits, and then we can do one without the sure markers?
Well,
Sure, Mark.
I wouldn't.
Well,
I wouldn't care actually.
I wouldn't care,
We should be
actually.
able to take care of it.
Well, we should be able to take care of it anyways.
Let's see how it goes.
Okay.
Yeah.
We'll see how it goes.
Well,
Yeah.
actually, I
Well,
accidentally
actually,
cut too much.
I accidentally cut too much here.
So let's just follow the
So
workflow
let's
here.
just follow the workflow here.
We finished the model
Should be okay.
registration.
We finished the model registration.
And if you look at the workflow here, we have this step called virtual tissue model. What we actually do is we will extract this surface to treat this surface as a patient's soft tissue. So let's go take a look. So we want to completely see the soft tissue site of the radiographic guide, and then we check this box, telling the system this orientation is right, and it generates the virtual tissue model. As you can tell from here, it's surface model. It's under the radiographic guide. So by default, this is not showing up here. So it's like a patient's soft tissue. And the color maps, we are map the colors according to tissue thickness, basically the distance between the bone structure and the radiographic guide is the tissue thickness. For example, if we take a look at this spot, we have about 5 millimeters soft tissue. That's this area. Now in the yellow area, that's thicker soft tissue thickness, and on the tooth area, it's thinner. From this view, you can tell the left side of the patient and the right side of the patient, they are, the left and right side, the colors are about even, meaning the radiographic guide, either the soft tissue is quite even or the radiographic guide is placed properly. If you look at this view, we are not seeing any gaps between the patient structure and the guide itself. But sometimes we have seen clinical situations when the patient gets scanned, the radiographic guide is not completely done, sit in place. Let's say it tilts. Instead of being like that, it's a little bit like this. In this case, you're going to see uneven colors on the soft tissue model. So in other words, this color distribution can be used as a quality control tool to tell whether the patients might be not scanned properly. So we can use this model for this purpose. And on the other hand, we use this model for restoration design. We can export this file for restoration design. It's like you have done the actual patient scan with InCharge scanner. So we can use this model for that purpose too. So this is a virtual tissue model. And next in the step is nerve channel definition. We don't have anything for the nerves. I mean, for the upper jaw, we don't have to. Occasionally, people want to do create something here, so to create a model so that to show the patients or show the doctors this is area need to be avoided for treatment planning. But actually, for this case, we have plenty of bones, so we don't worry about the anterior area at all here, in center area. So let's go to actually implant placement in the next step. Before that, we need to adjust the arch curve for the treatment planning. So because we are working on the upper jaw, we want to adjust our arch curve to this level. Just roughly follow the bone structure. Then we go to the next page for implant placement. You see here we have this panoramic view of the bone structure, and we can place implants already here. Let's say we want to start with supposedly we want to do an 014 case. Just assume we start with number 3, and we pick the library from how implants. For the posterior, let's say we do 5 by 13. I think for this case it has enough bone. It's 5 by 13. And for abutments, we can do, for example, we can do this multi-unit abutment 4.5 or whatever you have you think is appropriate. So we'll choose that implant abutment. We just click and place the implant. Now you see here we are showing the glidewall sleeves, the implant, and the abutment. Now we can adjust the implant positions. For all 4 cases, maybe we want to go a little angle like that. Now let's take a look at this view. We can see the implant, we can see the soft tissue, we can see the bone. And if we right click, we can show the radiographic guide, so we see where the implant will go out. Of course, we're going to use angle abutment, so it's not going to be here, so somewhere here. But if we want to take a closer look, we can use this cross-section view. We can use mouse button to rotate. You see this cross-section is corresponding to this line. So we can do a 360 view of this implant. And we do a similar thing here. That's how we inspect the implant positions. And now let me turn off this one, and let's place another implant. Let's say we're going to place tooth number 6. I'm going to choose a smaller implant. Let's say we do 3.5 by 11. That's the implant we used for in the last demo. I mean like earlier video we created. I'm not sure if it's actually what you use, so I'll just pick that one. So we place an implant. Now we have two implants. So for the implant movements, we drag the implant, rotate as this, and we can also move the implants in this view. So whenever you want to move, you can move the implant from here or rotate. And we also have this implant centered view. So that will give us a view that always place an implant in the center. So for example, if we rotate, it's going to go back that way. This tool, this implant centered view is helpful for you to better place implants locally against the surrounding bone. But if you look at this picture, you don't really have a good idea where it is and how it's related to the entire plant. So we still have to use the 3D view, or we go back to a regular panoramic view to see how the implant is related to the other implants. Let's say we can move it this way. Additional functions Brian has played already. For example, we can edit the implant, make the implant parallel to the left one, to the right one. Here we actually mean left on the screen, not the patient's left side. So just a little reminder here. And we also can report the angles between the implants. For example, right now you can tell us they have 90 degrees between the two implants. We have this reporting. And if we have multiple implants, this table will go longer, just to tell us all the implants angles. In production environment, very often what we do is we'll place all the implants parallel first, then we adjust. That way we can know what's the minimum adjustment we need to have a better plan. If we just do them one by one as I just did, so eventually it may take a little longer to adjust implant positions. But if you start everything in parallel, it's probably quicker. And let's say if we want to make a copy of the implants, we can copy this one. Let's say we make it 2C11. So it will go to the left side. And of course, it's when we do a simple copy, it's parallel to the first one. So we want to move the implant around. Actually, let me make this one a little vertical too. If you look at this view, it's here. So we can use the 3D window to adjust this too. If we want to check against the 3D bone structure, we hide everything. We hide this one too. So you can tell how the bone structure is related with the implant. So those are the abutments. If we want to see inside of the bone structure, right, we want to make this translucent so we can better see where the implant is. Considering later on we probably want to do a bone reduction, then we can push the implant lower by just, for example, we do that. We can push it lower. Of course, we can always adjust the translucency to see the relationship between them, or we go back to the 2D screen to verify their relationships. So that's how we place an implant in general. So we have two of those, and if we want to look at this view, we probably want to do a little more adjustment for this guy. So all kinds of ways to adjust the implant positions. Now let's say we do the last one. Let's say we do 14, and we choose 5 by 13 again. So this is basically how we place implants. A couple of more things here. Take a look at this abutment thing. As we are using the as we are choosing a stock abutment, we don't have much to play with this page, which is to adjust the orientation of the angle of the abutments. But if we go back to the abutment choices, so we actually are using straight abutments. We can use angular abutments. Let's say we choose 30 degrees for this one. Now we change the abutments, right, to a 30-degree. Let me turn off this. So you can see from here. Brian, last time you suggest we have the longer shaft. I don't quite remember if I get it already. So because
No, they IT designed or Grant designed them for me, and I just installed them on mine. I'll make sure to send you a copy of them.
All right. So in that case, if we have the longer shaft here, we can see it more clear where it's exit out. So additional thing I want to do is, let's say I'm going to go back to this one. We'd edit this implant. I'm going to choose no stock abutment. So this way we have you see here a virtual abutment which is on here. Now I'm going to play a little with this abutment choice. Let me hide this one for now. So you see this is the implant and the bone structure. Let me show back the virtual tissue model. We show back the tissue model. So this is about the occlusion surface, right? And this is about the normal orientation. We see the occlusion surface. But if we really want to make it more accurate, we have this clipping datum plane. We can play a little with that. So, I'm sorry. I'll adjust the implant later. Here. Let's say this, I'm trying to align this plane orientation to the occlusion surface, something like that. Then I go to this orientation. When this axis becomes just this arrow, I know it's the screen orientation is about the right orientation of the occlusion surface. Now take a look at this implant now. This was what we were working on with the virtual generic abutment. Now I'm telling the system to automatically determine the angle for me. So it tells me the abutment angle is about 20 degrees. So now let's take a look. So you see it's 20 degrees from here. It's 20 degrees go out the soft tissue. If we bring back the radiographic guide, it's on this aerial, so we know it's a bad spot, so we can better adjust that. So this is something we have for the abutment angles. We can use this to determine the orientation, to adjust our treatment plan, to adjust orientations for the abutments. So for this case, now if I adjust my implant a little like this, or I move to, for example, if I move a little bit more to the medial side, then I can have a better position of this abutment. Then we can readjust.
Frank?
Yeah.
Hold on, we had a question from Dr. Manalili, and I have a question on the abutment work that you're doing there.
Okay.
The rectangle that you were just playing with across the whole arch, like the plane,
Yeah.
to determine the angle of the multi-unit, that you can do on top of the radiographic guide, right?
You mean this one?
You mean this one?
Yeah,
Yes.
perfect. Okay.
Yes.
Yeah, I just wanted to see that. Okay.
Yeah, it's.
But now you pick that plane.
So how do you pick that? I would pick that plane based on the orientation of the T.
Well, it's
Is this?
it's okay. It's
It
just
doesn't matter.
it doesn't matter. What I'm trying to show you is we have this plane. We actually also have this one, which is 3 planes. You can use either one of those. We use this plane to determine occlusion orientation so that when we rotate to the screen direction, we know the occlusion is perpendicular. The orientation is perpendicular to the screen.
So that's all you're using it for.
Yeah. So I use that to
Just-
determine the orientation.
But the glass of your computer screen is here, and the occlusal surface of the teeth in the same direction as the glass.
Right. So wouldn't you always do that on top of the guide? How do you do that without the guide?
I think the only purpose for this is to calculate the precise angle for that
Implant.
freestanding abutment.
Yes, for an abutment. Yeah. To make sure.
So that's all.
Very sure I'm choosing angles based on the T. Not
Yeah,
the
well,
red.
we're also choosing angles based on the 2 fixed multi-units we have. We have a 17-degree multi-unit, and we're not making custom multi-units.
Yeah. See,
This
you
is
see here.
This is just a little detour, right?
Yeah. See, you see here. After I adjust, it becomes 18 degrees. So this gives you a better position that you can use a 17-degree multi-unit abutments.
Yeah.
It's helping you to decide what about them, but I'm saying we want to know it's based on what the T guide.
Right, absolutely. Frank, kind of what we do, at least when I do it, is I can pretty much guess a 17 or a 30,
Yeah.
Yeah.
and then you spin it around and move it around and spin it until you get it where you want it.
Yeah.
'Cause it's kind of a combination of implant placement and abutment angulation. I don't know that I want to mess with the custom dimensions there, but I see what you're getting at.
Yeah. So.
But I think we've only got 2 choices, or 3, straight 17 and 30.
Yeah, it's the same thing. If you create a longer shaft, right, you can just spin it around and find the best orientation for that.
Yeah, well, yeah, and then the ones I'll send you tomorrow will have the shaft on
Yeah,
them.
yeah, okay. Well, so otherwise, this is just for the situation. We don't really have multi-unit abutment.
Yeah.
We want to custom
Without
abutment.
this.
So we find a better angle for this. All right. So this is not very often used, I would have to say. And also we can play with the parameters of this virtual abutments like the collar height, the upper diameter, the collar diameter, etc. We can play with those parameters. So that's for the abutments. And the third thing here is sleeves. As we said, we are using the Hong implants and the sleeve, so we don't really mess up with this. But in general, I want to mention in the system, we have 3 levels of draining sleeves control or the holes on the surgical guide. So one is according to the surgical kit. That's what we're doing right now. So we just go with the sleeves, the kit. And the second choice is for entire project. For this case, let's say for 4 of the implants, instead of following the surgical kit, we want to say, hey, I only want 2 millimeters holes for everything. That's project level control. We can do this by changing implant one by one, or we can have an option at the surgical guide design time. This page is the 3rd level, is the implant level. You can change individuals. Let's say for this single implant, assuming you have an anterior case, the patient doesn't have enough space for the sleeves. Then you want to say, hey, I want to customize this only to 2 millimeter drill for me. For example, I don't even have a sleeve. I just do 2 millimeter drill. You can do that. So that's to customize the individual holes on the surgical guide. Obviously, for this case, we're not going to do that, but this is the option. Similarly, we have more flexibility in the depth control of the surgical kit. We covered this last time. So in general, we just use Hong implant surgical kit. But if we really want to make any changes, because if you look at this one, the sleeve gets into the bone structure, get into the tissue a little bit. So let's look at other sleeves. This one is lower. This one is lower than the tissue surface to all of them. Then, well, either we need to move the implants up, or we can choose the longer drills. So that's by default by the surgical kit. For example, for this one, that's where we are. But we can use this tool to automatically control the draining depth, basically to choose the length of drills. Let's just look at this one, where it was right now, and after I click this button, it's going up. So it's actually chooses the right length of the drill for me. It chooses 22.5 drills for me, and this implant is 13 millimeters, so that's only just 9.5 millimeters prolongation, which is good. And if we look at this one, it also goes up. So this adjustment is for the purpose to avoid the situation draining sleeves are lower, cutting to soft tissue.
Yeah, Frank?
Yeah.
Now with the Han surgical kit, we're stuck with whatever prolongation we've got.
Yeah, in that case, you just
Yeah,
choose
because
this.
because it's tapered and fixed. Now, if it's another drill system with parallel drills, we could get away with it, but I'm terrified of telling a doctor that they've got to set their stop at 22.5 millimeters. I don't know a clinician who could do that.
With those drills, right? It's not for having them to set the stop. They just choose the length. So for the kit, it's assuming it's all parallel. Then we have all kinds of lengths. The doctor just choose the right length for the case.
Are drill kits set up that way?
Yeah, they have multiple lengths. The only thing is the shape. The shape are different. So that's the problem with the tapered drills.
All right, yeah, I would be cautious before we go that way, but
Well,
okay, you, hmm.
basically what we do, right,
Basically, what we do,
is
right,
for
is
we are
for
using
we
the
are
drills
using
for
the
longer
drills
implants
for longer implants
if the sleeve positions
if
are
the
bad.
sleeve
But
positions are
right
bad.
now we can just
But
stick with
right now we
this.
just with
We can just
Would
stick
that
with
apply for the tapered also?
yeah.
yeah.
Well,
Oh, really?
no,
Okay.
I'm sorry.
No, I'm sorry.
I'm not sure. So
I'm
for
not
the
sure.
drills,
So for the
we
drills,
are
we are
just assuming they
just
have similar
assuming
shape
they have similar shape
on the apical.
on the apical area.
All right, well, let's skip the prolongation. Let's stick with prolongation by Kit, and then you and I and Ruben can have a sidebar about, because there are times when you want to place an implant, the patient's got 8 millimeters or 6 millimeters of soft tissue.
Yeah.
You don't want to do a flap, but you could place an 8 millimeter implant with a 13 millimeter drill if you slide the sleeve back far enough.
Right. We just need to look
We do
at
have to worry about the shape.
we just need to look at
We
the
just
design
need to
of the
look at
drills, I
the
guess.
design of the tubes.
Yeah. But let's table that for now.
Yeah.
Let's just stick with prolongation
Yeah.
by Kit.
Okay, so we'll do that.
Okay, so
let
we'll do
me
that.
adjust
So let me adjust
other implants too.
other implant.
So I'll do that later. So we have this depth control, and this is to make implants parallel. So the new implant will be parallel to the previous one, and there is also a choice under Object Manager. So I guess we haven't covered this before. So you can choose any implant first as your base, and then you use Control key on the keyboard and left mouse button to choose the rest of the implants. Then you click on this button. They will make the 3 implants parallel to the first one we selected. So there's another option here for making implants parallel. Just we don't have to do this now. Just mentioning there is this tool. So another thing for implant placement, I guess the doctor doesn't care, but the technicians may want to take a look at skin abutment. So you can go choose how implant skin abutment we choose. We can do skin abutments for individual implants, or we can choose one for all. Let's say for now we are choosing one for all. Now we are showing the skin abutment here. So for restoration design purposes, what you can do now is go to the menu Project, Export, Scan Template, which is a radiographic guide, or the soft tissue model, the implants and the sleeve. Or you can choose template, implants, and abutments. Or you can choose all abutments and implants. So you will have different options for you to export STL files and take into ExcelCAD or 3Shape to design the restorations. So those are for the scan bodies. For now, I can go back to a regular abutment display. So this is for the treatment planning. Pretty much we covered everything. And there's another one is the safety zone, which we have a safety area for the implants. So it's 1.5 millimeter that's surrounding the implant, and it's actually half millimeter more on the apical area because we are considering the drills has typically half millimeter tip, so it's slightly more here. So that's the safety zone. That's pretty much everything we have for the implant placement. And after we are done with the implant placement, we can go ahead and place anchor pins. So for anchor pins, we want to place them not on the same plane, and the bigger the angles, the better. So we don't want them to be in closely a parallel orientation. And actually, we want, if possible, we always want one pin in the lingual side, 2 or 3 on the buccal side. Whenever possible, put one in the lingual side, because that really helps stabilize the surgical guide. I've seen so many cases, so people place anchor pins like what you see normally on the in Nobel's website or the cases. You put one here, you put one here, put one here, yeah, about same plane, same angle. So when at the surgery time, actually the guide can be pushed towards the lingual side very easily because of the pin positions. So we always suggest, if possible, put 4 and one in the lingual side. We always suggest that. So right now, let's say we place one. We have so pretty much those pins are the same. The only thing we have implemented differently is dentist anchor pins. We can take it out and or we can replace with Hans anchor pins. Right now, I guess it's still about the same as Nobel's anchor pins. And the sleeve parameters we're going to replace with yours. So we click on that. We click on this button and we click on the radiographic guide. We can add anchor pin. Here, let's say we put it this way, and we go up. We see typically you want like 4 or 5 millimeters deep in the bone. So this is not enough. We want to go a little lower. So we place one here, and then we'll place, as I said, if possible, we want to place one on the lingual side. So you can place on anywhere on the screen to add the pins. Let's say we want to do that. Oh, sorry. So when it shows red, meaning it's interacting with the implant, which is not good. So we got to move it out here. So we can place anchor pins like that too. So if it's too much on the lingual side, we can move it out. So this is where the pin is. And then let's say we want to place another pin. We want to go on this side, for example. So we can use any of those views to adjust. We can do that too. Oh, so this is another pin. So you probably are, yeah, they are too close. Let's say we move a little. Or maybe I should have moved this one. So I wouldn't spend too much time on the anchor pins. That's pretty much it, how we place anchor pins. There's a special thing here we call it plan area simulation. Typically you don't have to go here, but I just want to show you. So this page we consider the registration of the error of the two data sets, the pixel size of the CT scan or the error source, and we have we can have printers, 3D printers errors. Let's say typically they are in the 75 to 100 microns range, and the linear precision errors of the guide, for example. So we angular deformation, we just assume 2 degrees, or then we assume those manufacturer or surgical conditions when we can simulate where the implant will end up with. See, this gives us an idea in extreme situations where our implant can end up with. So for this case, fully edentulous, we don't really have much to worry about. But for partial edentulous cases, some rare situations, you don't want to get into the adjacent teeth, you don't want to get into the sinus area. So this will really help you to determine under manufacturing errors, under the current data sets, what kind of errors we could expect from the surgery, from the handling of the surgical guide. So this is an error simulation. It's, I would say, for doctors who wants to showcase their designs, it's interesting, but regular production may not use this one. I would have to say that. This is for error simulation. And one more thing we didn't cover is here actually to show the bone density surrounding the implant. So for each of the implant, we can show the colors of the, let's choose another implant. We can show the surrounding bone with the colors, meaning we can inspect the bone density in the implant area. So we can see on the, for this implant, the average bone density is about this range. It's probably okay. But for the on the apical, we do see lots of areas with very, very loose bones. So those are the things. So this gives the doctors some idea how the bone density is and how the bone density is distributed surrounding the implant. So we can do that. And we actually, Brian, we haven't showed you this, but we actually have another one under diagnosis. We have this neighborhood viewer. So what it does is to show you the surrounding for all the implants. So when my mouse is in this view, it's dynamically changing this one. So you can investigate this. And if I'm on this view, my mouse can be off the middle line. If I go further out from the middle line, it shows a dynamic range, a bigger dynamic range. If I am in the center, it shows smaller range. So we can do this automatic. So I'm just moving my mouse there to do the inspection. It's a convenient tool. You don't want when you don't want to scroll through the slices one by one. This helps you to look at that. That's pretty much for the placement. Now I go back to stop this function. And then for case communication, documentation, we want to do the bookmarks things. Let's say I want to, for example, I want to capture this image. I press on this button and I'll type any comments, any notes for the doctors, for technicians, etc. So I'll type something here. And then, for example, like this one, if I click on this, then I can do a measurement. For example, I want to measure how much bone I have on the buccal side. So we know it's pretty safe, right? In this case, I type that, I just capture this image and write whatever I want to.
Actually, for real,
Yeah.
why don't you measure from the implant platform to the incisal edge of the tooth?
Oh yeah. Yeah, you can.
So we see how much restorative space we have there.
Yeah. So you want to go from here
from here
to the edge?
to
All the way to the tip of the tooth.
It's somewhere.
somewhere.
You can scroll out.
Yeah, you have to scroll way
We
down.
don't have the tooth
We
here.
don't have the
We
tooth
only
here.
have the bone.
We have the bone.
You want to go all the way?
No, you got the
You want to
tooth.
go all the way.
So that surgical guide will be what the teeth look like in the end. So you have
Zoom
the
out.
picture.
There you go.
Oh, you want to
There you
go all
go.
the way to this spot?
Yeah.
Okay, yeah.
Okay.
So
So,
let me see.
That's actually one Dr. Manalili wants to see,
Oh,
especially in the anterior.
so for this case, right? 16
in this
millimeters.
case,
That's probably too
16
much.
millimeter, that's probably too much.
Nope, that's actually just about right.
All right. Okay.
All right. Okay.
So
Yeah.
after we
Yeah.
capture the
So after we
dimension,
capture the dimension,
we capture this image,
we capture
and we
this
tell
image,
whatever we want to tell the
tell whatever we
technicians.
want to tell the technicians.
Yeah, because
It's
that,
actually super.
So all those pictures and the dimensions and other pictures will get into the report. They are
Get
here.
into the report. They are here.
So those are the pictures we captured.
Those are the pictures we captured.
you guys hold on. I need to use the restroom. You guys still good here?
Okay. So yeah, we'll wait for you.
Of 10. Hold on 1 second, Frank.
Okay, no problem.
Okay, no problem.
Thank you. restorative platform to Invisalign, I should say.
So are we back?
But like according
So we're
to,
back.
Yeah, we are back.
Okay. So those are the pictures we can capture, and we can communicate the cases through those pictures. Let's say, for example, I'm looking at somewhere else right now, or I open this project, it shows me, takes me to somewhere else. I can go ahead, tell the doctor, hey, I go to this page, say, hey doctor, this is your first implant. So I double click, it takes us here. So we will see everything. Then we say this is your second implant, and then your third, so this is another one, whatever we want to tell the doctor, right? So those tools will help us to communicate the cases with doctors or with technicians. So this is our screenshot or bookmark tools for the placement. And let me bring back my radiographic guide here. So right now, actually, we can show the radiographic guide on the 2D2. So somehow I messed up the sleeve position, so I'll go back there. Because last time we didn't finish the adjustment of the sleeves. So this is bookmarks and snapshot functions. And this object manager we can play with. Those are the objects we created down the workflow. The anchor pins, the abutments, implants, virtual tissue model, etc. So on here, you can double click anything, it will bring up the model into here. For example, I double click this one, I'm going to I can evaluate my tissue model, or I can double click on my radiographic guide, it goes here. So all those things can be taken into here. And there's one more thing I want to show is before we go to surgical guide, is for radiographic guide. If you look at this one, as we know, it's from the denture. It has a pretty good shape, very nice. But in some situations, we have seen radiographic guide which is made too short. The flange is too short. There's no space for the anchor pins, for whatever. So in that case, we have additional functions to fix that. So if we look at here in this toolbar, let me drag this one lower. We have this touch up, which is used to modify the typically STL files models. We have this local deformation, and we have this global deformation. We use this one to do the virtual teeth last time. If we take a look at local deformation, let's say I click on this, it creates a box here. But if I want to, for example, if, as I said, the flange is too short, I want to fix the flange. What I do is I'm going to double click on this, on the edge. So I can rotate this tool by clicking on the surfaces. I can zoom in and out, make it bigger and smaller. Now what I can do is I can drag this guy. If the flange is really too short, I can make it longer. Or if I don't want to hit the patient's anatomy, I can go out. So that's a little tool, but which is very helpful for actual, production. When you never know what kind of things you get from the doctors. They may or may not be familiar with scanning protocol, the preparation of the cases. So this local deformation tool is helpful for making the to adjust the radiographic guide. So I'm going to click on that to finish. And then additional thing for the radiographic guide is for production sometimes
Hang on, Craig.
Yep.
Right, we were just having a little sidebar on that because that is a problem very often. The denture or if they make a duplicate denture, there's no flange coming up the vestibule. And
How do we know the depth of the
Yeah.
It's not enough.
Yeah,
if it's not an impression and you don't know, you could be toast. You have to ask the doctor. The only other option is the doctor would have to take the denture, duplicate it, manually extend the flanges, and then take another CT scan. But they're not going to be really open for that.
Yeah.
At this point, your patient's already had the CT scan. If you want to change the geometry of that on the actual denture or duplicate denture, you're going to have to call them back in for another scan because there's no way the fiducial markers
And the
ever
reason I'm
going to
asking is because sometimes the duplicate denture doesn't go all the way to the depth of the vestibule, where in turn it's short for us for the guide pin.
Right.
For the,
But we'll ask for the impression to go all the way up the vestibule.
Here.
Yeah.
But most of the time, they still won't do it. They'll just take whatever denture's there with a short flange and do it. At least this way.
Yeah. This way you.
Yeah.
It won't.
You have
only
a
impact
tool.
fate. Yeah.
yeah.
You at least have a way to do it here without requiring another CT scan, but it is going to require the patient, the doctor to tell you how deep the vestibule is or send you something. Or,
Yeah.
big issue.
yeah. But at least you could ride in on a white horse with this and say, you know what, doc, if you've got enough vestibule, I can bring this up 10 millimeters. Will that work?
I mean, it moves. I mean, the depth of the peripheral will move a little bit, but I
Yeah.
mean,
And we
I
may
don't
have
want something
to,
in the patient's mouth where it's like making them gag.
I mean, we could then take this with our extended flanges, print it and send it to them and say, recall your patient, try this. Yeah.
Right.
It's better than another CT scan.
Yeah.
All right, that was it. That was an important discussion, and it was a consistent problem with Nobel Clinician because we couldn't extend the flanges. We had no tool.
Yeah. Yeah.
Fun.
Yeah.
Okay.
Thank you.
All right,
Continue.
thank you. So additional thing, we have seen cases, the technicians especially for small labs, they want to save materials, right? Object material is quite expensive. So what they do is they are going to trim the radiographic guide. They cut away the palette area. It's a very dangerous move. So I want to mention that. Because when the radiographic guide or the denture is made, they fit onto the patient's mouth as the entirety. So it doesn't necessarily mean everywhere it fits. We cannot guarantee that. So in case there is any gap in this area, you cut away the edge so the guide will not be the right position. Because there was a gap here. So when you place in the guide, it will go lower, so it will tilt towards the lingual side. It's not a good suggestion or practice to cut the radiographic guide this way. If you really want to cut this way. We have two. When we do the segmentation, we have the cutting tool there, and then we have this tool. We can trim. We can cut by profile, and we have this function. And we can cut a hole here. If we don't like the points, we can use the delete key on the keyboard. Oh, wait a minute. Oh, whatever. So we can use. Let me do it again. Wait, I don't know why it's not. Let me do it. I guess I better off go back to here. Segmentation, and I use this one. This will. Wait, I don't know why it's not working. Let me see. That's so strange. I'll check this later. So the point I want to make is don't cut this way, cut through, just still keep the edges here. It will maintain the fitting of the guide. So that's additional thing I want to say about the radiographic guide. Then we can go to design the surgical guide. This is a regular full arch case just to generate the guide. Go in here, you don't need to do anything, just click this button to generate the guide. We have additional choices of surgical kit and some parameter control, thickness of the guide. It doesn't apply here. We use this as a base. And we have an undercut angle. It actually doesn't apply for the radiographic guide case. So we just use this button to generate. There are a couple of other buttons here. This one is to generate what we call the positioning guide, meaning there's no implant holes, just anchor pins. So let's say we are placing 6 implants or maybe 8 implants. For sure, if you place 8 implants, there is going to be no teeth remaining on this guide, on the surgical guide. So everything will be cut away. In that case, you have no way to guarantee the surgical guide will fit onto the patient's mouth as it should be, because the tissue is flat, the guide can tilt, can shift to the left and right. So we use this positioning guide function to generate a guide with only anchor pins, so that we can make sure we can maintain the occlusion by using, for example, bite registration. Then we can drill the anchor pin holes at the right position, and then we take out this positioning guide, use the surgical guide for the drilling. We using the same anchor pins. This is one way we can do for this for the positioning. And another one is to generate the guide with abutment holes. So if this one is restoration instead of the radiographic guide CT, if it's a restoration design with actual tooth anatomies, then we can use this one to generate the temporary restoration with implant holes. So it's still working on the surgical guide.
Hold on now, run that last one by me again. Generate update guide with abutment holes.
Yeah. Let's say, as we said, we always say we can support multiple data sets, right? If you have the radiographic guide and you also have an actual denture design, you have an STL file of a denture design. Instead of this physical denture, you have a feature design, or you scan the denture, the STL file.
Okay.
You use that one as a radiographic guide, use that as a base to generate the guide with abutment holes.
And then I would then go manufacture that
Yes,
as my
exactly.
acrylic or peak temporary?
Yes, exactly.
Okay.
Actually, we in my machine
So it's got a big
here,
hole in it, I'll use the temporary cylinders a little.
yeah, actually on my system, it doesn't say I have the right license here. In your system, you can check. There is another one called what is that? One and down guide. It's to split the guide into 2 pieces. Sometimes people could split it. So the upper part has all the teeth, the lower part has the surgical guide. That can also be used for restoration.
right now with this, you could use a standard bite registration,
Yes.
put that in the patient, have the bite, drill the 3 holes, and you're good to go. But now you could even do it here.
Use this as the guide for the whole placement.
Yeah, you
on
have
the
those
denture.
teeth, so
Not
you're
this.
good for the
I'm just talking about
position.
aligning it via surgery. There's enough teeth there. I would still recommend you mount everything up and make a bite registration that's got that on one side and is opposing artery on the other side.
Yeah.
But there's, you know, it's
We
clinician preference.
always would use bad registration.
No, I think they're not comfortable with it. But
So this second one is to create the guide without any of those implant sites. This one is restoration thing. So it's Brian, how much time do we still have for today?
Well, I have the room till 6. I was only planning on being here till 5, but we need to see the bone reduction part of this.
Okay, so let's we'll finish the guide design. So let's do the bone reduction guide for now.
Good.
So in order to do bone reduction guide, we need to cut the system first. We want to do a tissue and tooth bone surgical guide. And actually before that, I need to go back to evaluate, to take a look at my bone model, because I briefly mentioned this earlier. We want to cut it small. So for bone reduction guide, in order to avoid unnecessary problems, those things tend to cause issues. I'm going to do another trimming to this with my scatter removal tool. So I'll trim this area for now. So for bone reduction guide, we really need to trim the bone model to the minimum. It's still quite a bit, but I think we should be fine with that. I'm going to take away this area too, because those are the areas which actually can cause trouble. I want to avoid those things. Okay, now let's go to the bone reduction surgical guide design. First, we tell the system we want to do tissue, bone and tooth bone guide, mini bone reduction, bone level guide. Then we go to bone reduction. You see here, I actually should have reset this because we were doing the tissue level guide. So I'll reset this and I'll go to bone reduction.
Yeah, I think all your implants are in a good place, so you don't need to remove those.
Well, I need to reset my type because it was still the bone tissue level guide. That's weird to me. It supposedly take me back. It's supposed to take me to the bone structure. Okay. Now we go to the bone reduction guide. We see the bone structure here, and we got the implants, everything. So this cutting plane is by default it's vertically placed. So I just need to rotate this to where we want to cut the level. So let's say assuming we are going to only cut the bone area for the anterior area, teeth. So we adjust the cutting plane and we define the area we want to cut. So let's say we
Yeah, that actually is right. We were only going to cut really mostly in the anterior.
so let's say we cut this way, right? We cut those area, then we adjust how much we are going to cut. The plane, remember the plane is where we set as pretty much the implant platform side. So let's suppose let's say assuming we are going to cut this way, then we do a preview of the bone cutting. So we cut the bone structure and we have this platform here. Then the next, we're going to define the area we want to have the surgical guide. So we find an area on the base and we cut it. So we do typically for bone reduction guide we really don't use this checking function. That's as we show on the tooth level guide. So we do this one. We do circle. It's like a cookie cutter. So we go around the implant side. And we cut it. One thing to remember here, if you go clockwise is to keep material. Anti-clockwise is to remove material. So if this time I'm going to anti-clockwise, it's going to remove this lower piece. We'll need to look around and to find those area like those sharp corners. We really want to get rid of those. We do the same thing here. So basically, this is how we trim the base surface for the surgical guide. We don't want to have anything on the sharp corner like this, so we can do further trimming of that. So we don't want to go too far on the molar side. So it's pretty much it. And for here, we may want to cut too. So we will do one more cutting here because that's it. We cannot have this much on the lingual side. So after we prepare the base for the surgical guide, then we can generate the guide. We have two ways to generate the guide. One is to do two guides, one for the bone reduction and one for the surgery, and they come with two guides with the same anchor pin places. So that generates this guide and the surgical guide, so two steps. And another one is to generate the stackable guides, so two guides at a time. So after we click this button to generate two guides, and then we add additional material so they can be connected, they can snap in. And before that, if by default we're going to have a undercut orientation with the average direction of the implants, but we can adjust that by using this button. Let's say we want, because it's a sharp edge here, so we want to do something like this. If we want to do something like this, we go this orientation. We click on this button. We don't have to, but this probably give us better results. Then we generate the guides. I'm going to create 2 guides at a time. Yeah, this guide generation takes a little while. While this is working, let me start another session. I'll show you what we did for the Chrome-like guide. We're still working on that. So we actually modify the design a little based on this case. So we change the design. We make this bone reduction guide wider, you can tell from here. We make it wider because the wider it is, the accuracy is better. So the guide can sit much better on this one than the thin guide as what you see from Chrome. So we make this wider, and the surgical guide design itself, we have actually 2 steps. For the first one, for the positioning, actually we put this guide, we attach this guide to the entire model, put onto the patient's mouth, so we can determine the anchor pin position, drill the holes, take out this piece, and then we have this bone reduction guide in place. And then we make the surgical guide. We put on the surgical guide. You see here, major thing here, the positioning. We're going to change this one a little too. So we sit on the bone reduction guide because this is thicker. We can expect better accuracy on the lingual part, on the lingual side. This is done per a doctor's request. He wants to partially sit the guide onto the soft tissue, but eventually we're going to change that. So what we are going to have is we're going to have something between this guide and the bone surface. We're going to have some adjustable structure on here so that it sits onto the reduced bone. So we're still working on that part. So we finish the, looks like we finished the surgical part, first part of the surgical guide design. Now it's splitting it into 2. It's a little longer than I think. So we finished the this is display artifacts. Forget about this. So let's say we say here we have the two guides already. We have the two guides, and if what we want to do is we want to connect. We want to add a connection between the two guides. So the next step here is to do that job. So I'm going to create a slot on this one. Actually, we can use middle button to.
Let me just understand what we're looking at here. Since you only did a bone reduction in the front,
Yeah.
those implants, that's a tissue-borne guide in the back.
No, bone level.
No, bone level.
That's still bone level?
Yeah, still bone level.
Yeah, still bone level.
All right, just no reduction.
Right.
Right.
So what we are
Okay,
doing.
okay, got it.
What
Yeah, that
we-
would be a tricky flap.
Yeah,
grade,
what
wouldn't it?
we're doing right now
Yeah.
here is we're going to place this square here so we can cut a slot on this model. Then on the top guide, it's going to have a square sticking out so you can snap in the surgical guide. So that's how we do the stackable guide. So you can add additional, add one here, add one here. Let's go back to the planning area. So you see this is the upper part of the guide. It fits onto the lower part. Hide this one too.
Which one is supposed to clip in?
You say it clicks in, but the one that I printed from you earlier, there's no clicking going on.
Meaning it doesn't go in.
Well, no, it was malaligned and it didn't stick. It comes off really, really easy.
Yeah, it's it depends on a couple of factors. Well, first of all, we didn't have any taper here, so it's a straight square. It definitely will be easily taken out. And another factor is the printer itself. I think we have like 100 microns clearance. So some printers may be accurate enough, but some may not be able to take that. So for your case, I think the printer is very accurate. We can reduce that clearance.
Well, when we designed this on our own, I'll have Tim print the jaw. I'll have him print the maxilla and the reduction guide and the other clip. That way you can practice once before you.
So it doesn't clip in, it's just resting.
It does. Yeah. The where we're having the problem is that the word click or clip in. There's no real retention there, is there?
No. For
There's
now,
just
it's just plug it in and take out, easily taking out. We can create a little bit of retention later, but right now we don't.
So if he offsets the square, can it be more stable that way?
We can make it tighter. You know, because the object printer got like 28, 30 microns errors. Right? We can make it tighter. So you can press in and it won't go out easily.
Yeah, I think if I was drilling the holes,
Yeah.
I would rather have it click in well.
I see.
I see.
again, or like,
This when, yeah, we're looking at it. We have a Chrome guide we're holding in our hands here, and it actually has pins
Yeah,
that hold
that one has
second
an
part.
intention anyway, because that's sort of pre-made or structure. We can't do that too.
We can't do that.
You can do that. They're working on the Chrome style design. Yeah, I'm going to want to print one of these. Obviously, it looks like those anchor pins two of the anchor pins are not in the best place for this.
Yeah, if you want to
Yeah,
print,
but-
you probably want to adjust the design.
Probably want to adjust the design.
Is there any getting Mac version?
There is no Mac version, but I do have a license for you for the software.
Okay, I gotta talk to them.
We just gotta have IT installed for you because we don't have an administrative privilege. Neither do I.
So Brian, you mentioned you want to print the bone structure, right?
You want to print the bone structure.
jaw model.
You want to print the jaw model.
So we actually have additional
So we
things.
actually have additional things here.
We can
We
create a
can
master
create
anatomy model,
master
which
anatomy
is going to be the bone structure with the implant holes, and also the tissue structure with the holes. So I'm not sure if I don't quite remember if we ever done for bone reduction guide for this one, but let's try that. So this is supposed to generate the. I have that already. That's me. This is supposedly to generate the virtual tissue the bone model with the implant holes. Oh, sorry. Yeah, that's a bad practice. I have done so much. I haven't saved anything. So let's try if we can recover the data. So I should have saved something in the middle, but I never did. So this shows you in case there's any crash of the software or even, for example, power outage, so, system will be able to recover the data till the last step, supposedly. Hi, Brian, can you hear me?
We're still here. What's up?
I say, did you say you want to print this
Did you
guide,
say you want
or
to
you want
print this
us to
guide,
adjust
or
the
you want
planning and
us to adjust the planning and do another printing?
No. We'll do our
Yeah,
own
okay.
and print from that.
Okay.
Because again, as I was explaining, we wouldn't plan one kind of guide and then plan another kind of guide. We normally just do one in a case.
Just the one in a case. All right.
I
I
just
see.
want, right, I see.
So you sent me a license for Dr. Manalili.
Well,
Thank you. I have not given
well,
that to her yet.
well, and actually, I didn't realize it will. You wanted the IT people to install. So that one must have been expired already. So all the licenses have to
Okay.
be activated when they are weak. So after they install the
All right,
software, then we'll create a new one.
Okay. The license is expired, so when you install it, they'll get it.
Yeah.
I'll talk to IT tomorrow about it.
And then, now, while we're waiting here, Frank, the free version of the software.
Yeah.
That does everything except print the surgical guide?
No, that one doesn't have the functions to process STL files, registrations.
Okay, so they can they bring in a plan or bring in a CT?
Yeah, you can bring a CT to the treatment planning. Then it can open the project files you create. I mean, the technicians create.
All right, so we have to send them a project file.
Right.
What I don't want the doctors doing is trying to import CT scans and plan and call us and expect us to give software support.
Right.
Because
We minimize the functions they have. They only just place implants, adjust the implants.
all right, I'll want to play with that just to be sure. That's all I want to give them.
Okay, we recovered that. We recovered that. Let me save this. It's been too much time. I haven't saved anything.
Do I put it in on the first training, Brian? This software has the possibility to insert like a two.
Yes.
Yeah.
Yes. He has a fun basic.
So what I was trying to show you is actually, where am
You can move it, rotate it, stretch it, and then hopefully with these other tools we can export everything with a scan body in there.
Oh yeah, because last time when we designed the bone reduction guide is removed by virtual tissue model. That's why we created this. Last time we actually cut this. That's so strange to me. I need to check what happened.
I wonder if you had two of them.
Oh my god. Okay. So let me recreate the virtual tissue model. Then I'll go back to surgical guide design. So under this mesh model, we can create the model with the implant hole. So this way you will have the bone structure with implant holes, and you can also change the size to analog size. You can also have a soft tissue model.
Why would we want that?
It's somewhere it fails. Some people they want to print the tissue model for them to investigate or to play in the lab. Yeah, I guess this is. I shouldn't. I'm sorry.
Welcome to my world. Welcome to my world, Frank.
I'm gonna open this. I'm sorry. At least I saved it. Yeah. So I guess I wouldn't waste your time here. I'm going to record that part to generate the bone model tissue.
Yeah.
after the training.
I mean, the clinician may want it.
So back to the question, I do have customers.
I do have
They print more
customers.
bone and they print
They
tissue
print more
with
bone and they
red
print
resin.
tissue with red resin.
Print model with what, I'm
They
sorry?
print the soft tissue with the soft
tissue with the
red
soft
material.
red
They
material.
put onto the the pink
They put onto
material.
the,
To put onto the
the
bone
pink
model.
material to put onto the bone model.
I did have customers doing that.
I did have customers doing that.
I remember that there's an operation there where it'll calculate the distance between the bone and the intaglio, and that's the soft tissue. You could print that.
But it's gonna be soft tissue or?
It would be, well, do you mean would the material be flexible? You would need the right kind of material in the printer. But I could see where Dr. Maitland would want a 3D of the bone, so she could put the guide on and kind of bench the surgery first, make sure that it's going to go where it wants, that's got the amount of reduction she needs. You could even articulate that. I suppose you could articulate a bone model somehow. I don't know how to do that, but well, you work your way backwards.
Right. So a lot of times I'll like.
Yeah, everything works from the bite.
In it. The whole thing would have to be black first.
Who would you want this work?
Who?
Who would mount these models?
We'd have to mount them. Yeah.
That's a, uniform or?
Or,
That's
however
not-
you set it up.
That's our SOPs are right, man.
I'm just saying, there's a lot of tricky ways I've learned how to do certain things. I mean, I know I can figure this out now. I'm just saying, who would do it? Our class department, or we would do it?
Yeah.
I want,
Those are the details I haven't quite connected.
I'm just
yet.
saying, are we gonna have a little tiny class department for? All we need is a sink in water, basically.
Yeah, at first that might how it is.
So Brian, I guess when it's back, I'm going to show the report generation to Dr. Marini, and then that's pretty much for today, right?
That's pretty much.
I'll generate another recorded the generation of the tissue
I
model.
recorded the generation of the tissue model later.
Yeah, record that. That'll be fine. And then, but regarding the generation of the document, that's in the previous version of the training that's already up.
Yeah, I just want to show the doctor.
Yeah,
Show this to the
just-
doctor.
No problem. So this is a lot more complex than single.
Well, actually,
Even
depends.
Actually,
If you
Depends.
don't really worry about
if you
buttons,
don't really worry
don't
about
want
the
to
buttons,
deal with the
don't want
bone models,
to
then what I did,
deal with the bone models and all that,
then actually it could be pretty quick.
then actually it could be pretty quick.
We have, if you look at the
well,
we express wizard video we made earlier for this case,
we made earlier
should be
for
very
this
simple.
case, it should be very simple.
So I want to show the model
So I was,
report generation to the doctor.
report generation.
Put
to the
any
doctor.
information here,
So put
doctor,
any
planner,
information here,
business name,
doctor,
phone
planner,
number, email,
business name, phone number,
and we can
email.
write any additional comments here. So basically, this is general comments for the case. Then we put in the logo file. We can browse a picture file from the local computer. Then we generate the report. And this is to check if we have any issues with the planning. Those are the small minor warnings. So we'll call it upper report 1. So the report generation is all automatic. It's going to create all the implant parameters, screenshots, and snapshots we have during the treatment planning, and also the training instructions. So that's the reports. This is going to be the Glidewell's logo, and prescription doctor's information, their business information, patient's name, date of birth, etc. And disclaimers that doctors need to sign it one way or the other. So we have this area for them to sign if you want a physical paper printout. And this is X-ray mode panoramic view we generate. We haven't showed that during the demo. I'll show you in a minute. So this is the implant parameters, and for each of the anchor pins, the surgical training instructions, what kind of prolongations we have, what drill lengths we have, and what's the steps for Hung implants. Basically now just 2 steps, the panel drill and the shipping drill. So they're all showing up there. And the 3D pictures, cross sections for each of the implants. And the final part is the pictures we captured with the comments we want to tell the doctors or technicians. So that's the report itself. About the X-ray mode here, if we look at this one, we have this function here to do a 40 millimeters reformat of the panoramic view in X-ray mode. The 40 millimeter means from the arch curve, 20 millimeters inside and 20 millimeters outside to the buccal side. So this is X-ray mode of the panel. We can also adjust the contrast here too. So that's pretty much the full arch workflow and all the functions. We have gone through almost all the little tiny details, and for regular production, we probably will not need so many functions there. So I guess we can have another demo videos to show the core functions instead of everything as we did today. Because Brian is too experienced, so I gotta show everything. Yeah, I guess Brian and Dr. Madanili and Ruben, that's pretty much it.
That's pretty much it. I'll show today.
Okay.
All right. Well, send me the video capture. We'll get it narrowed down, and I really want to try this. I want to get some models. I know Sergio is anxious to get going. Dr. Manalili is anxious to get going.
Okay.
Okay.
All right.
I'm not sure I can watch a full flap surgery without throwing up.
All right. I'll send you the video of
All right, I'll send you the video of
The
this.
video it. Post the video. You can't be there.
That I got. The very first incision gets me. When it goes from perfectly together to that little slit that starts to bleed, that's when I learn. That's when I want to jump. When it transitions from being normal to not normal. Once it's all not normal, I don't care. We'll see. We'll see. We'll see.
Frank, thank you very
Okay,
much.
thank you everybody.
Thanks,
Thank you.
Okay,
Have a good night.
everybody. Thank you. Have a good night.
Good night.
Thank
Bye-bye.
you.